All right, this is exam 3 for physics 202. Which of these statements is always true? Okay, resistors in parallel have the same voltage. That's true. Current for resistors in parallel is the same. That's only true if the resistors are identical. The equivalent resistance of resistors in parallel is bigger than any one of the resistances. Okay, that's not true. They're smaller, in fact. The sum of the potential for resistors in series is 0. That's not true either. The terminal voltage of a battery is always what in the electromotive force because of what? Is it smaller or larger? It's always smaller because of this internal resistance. So A is the right answer. An ohm is a potential of resistance. Remember, resistivity is similar, but it's ohm meters. That's for our R equals rho L over A. So to the circuit, if one of the 2 ohm resistors is removed, what happens to the voltage across the remaining resistor? If I remove this resistor, what happens to this voltage? It's the same. It doesn't change. These are independent parts of the circuit. What happens to the total current coming off the battery if you remove one of the resistors? Remember, if I remove a resistor, the equivalent resistance actually decreases. Or excuse me, it doesn't decrease, it increases. And so if the equivalent resistance increases, that means that my total current will decrease. I'm removing the current that goes through this resistor, so that current goes away, so my total current decreases. So the circuit, which of the graph represents the current versus time after the switch is closed and current is allowed to flow into the circuit. Okay, well initially you get a big current and then it gradually goes away, and that's going to look like A. You know, this also gives you a big current initially that decreases, but that's not an exponential function, so A is the right answer. Third prong in electrical outlet provides protection from faulty devices. Which of the following equations for this circuit is correct? Okay, let's see here. Minus 6I2, that's starting right here and going in this direction. Plus 10. Oh, it shouldn't be plus 10, it should be negative, so not that one. Minus 6. So that's right here going in this direction. Plus 10. That's correct so far. Plus 6I2. That's correct because I'm going against the current equals 0. So B must be the right answer. If the switch S is closed, what happens to the current through R1? Okay, well if I close this switch, that means that this resistance is actually going to decrease if I add R2 in, and that causes the overall resistance of the current of the circuit to decrease. So the current coming up through here, if the overall resistance decreases, that means that current increases. So B is the right answer. Turn a light in your house. What happens to the potential across other appliances on the same circuit? Well, that potential should stay the same because they're in parallel, and it does. Consider these wires where the current is labeled. What is the magnitude and direction of I? All right, 20 amps, 10 amps. That means I have 30 amps here. I lose 5 of that, so I must have 25 amps going to the right. Which of these statements about a household circuit is true? Not a series circuit. Oh, you had a question like this? They operate at the same current. That is not true. They operate at the same voltage. As you add more devices to a household circuit, the total current increases. Okay, that's true. Ground fault interrupt turns off if IN is greater than I out for any particular device. That's true as well, so C is the right answer. Capacitor is allowed to fully discharge, which represents the voltage versus time for that capacitor. So if it discharges, the voltage versus time is going to look like this. Remember that voltage is V naught e to the minus t over RC. Consider the circuit. Which of these equations correct use of the loop rule? We'll pause here for this second. Okay, so this is a little bit different for the loop rule, but it's still valid nonetheless. So let's just go through here. So I have plus V going in this direction. I'm looking at equation A here. Minus I1 R1, that's correct. Minus I2 R2, that's correct. Minus I3 R3. Okay, well that's not a closed loop, so that doesn't work. And notice here, I know the directions of the current, they're labeled here, but I know that those directions are true. Let's look at this next one, minus I1 R1, so that's starting here, minus I4 R4, and then it just stops. That's not a closed loop either, so this can't be that. Let's look at C, not that one or that one, plus I3 R3, right, that's going in this direction, minus I2 R2. Oh, that is a closed loop, so that's the correct answer. Let's just look at this last one. Plus I2R2 minus I1R1. Oh, it should be positive I1R1 because you're going against the current. All right, so C is the right answer. What happens to the equivalent resistance of a parallel circuit as you add resistors in parallel? That's going to decrease. All right, calculate all the currents in this circuit, including the magnitude and direction, and then as a bonus, you can solve the system by Gaussian elimination. All right, first, let's just write a few equations. I'm going to label my currents. I'm going to call this I1, and I'll call this I2, and I'll call this I3. Now I'm going to write some equations here. My first equation, I will take the left loop. I'm going to start, say, right here, and I'll go in this direction. So that's going to be plus 2 minus 1 plus 2I2 equals 0. Now equation 2, let's see, I will take the right loop, and I'll start right here. It's going to be minus 2I2 plus 1 minus 6 minus I3, and that's going to equal 0. And now for my third equation, I'll just do the junction rule. I2 equals I1 plus I3. Okay, now I can solve these. Look, I can solve this one right off for I2, and I find that I2 is equal to negative 1/2 amps. All right, then I can plug that I2 in right here, and I'll find that I3 is going to be equal to negative 2 times negative 1/2. That's for I2, plus 1 minus 6. And I find that I3 is equal to negative 4 amps. And then I can find I1 here. I1 is I2 minus I3, which is negative 1/2 minus a negative 4, which is, what's that, 3.5 amps. All right, so I1 is 3.5. I chose it clockwise, and it's still clockwise. Sorry. I2 we found to be negative 1/2. I chose it down, but it should be up. And then I3 is negative 4 amps. 4. I chose it, what's this, counterclockwise, so it's actually clockwise. So those are my answers, and now you can also solve it by Gaussian elimination. I'm going to write up my equations here. And let me just rewrite these equations here. So I have 0I1 plus 2I2 plus 0I3 equals 0. And I have 0I1 minus 2I2 minus I3 equals 5. I'm just rewriting these equations in this form, I1, I2, I3. And then I have I1 minus I2 plus I3 equals 0. Now I can write that in terms of a matrix. 0, 2, 0, 0. Wait, no, I messed up here. That should be not 0, but this should be negative 1. And then over here in my matrix, this is also a negative 1. Sorry about that. 0, 2, 0, negative 1, 0, negative 2, negative 1, 5, and 1, negative 1, 1. Zero. All right, so I want to put this in identity form. My first step that I'm going to do is I'm going to replace row 2 with row 2 plus row 1. So I'm going to replace row 2 with row 2 plus row 1. And I get this. I get 0, 2, 0, negative 1. Row 1 stays the same. When I replace row 2 with row 2 plus row 1, I get 0, 0, negative 1, 4. And then I get 1, negative 1, 1, 0. That stays the same. Right? So I just added these two rows and replaced this row with the sum of those two rows. Okay, now I'm going to replace, I'm going to do a couple things actually here. I'm going to take row 1, I'm going to divide it by 2. See, that'll get rid of this 2 right here. And then I'm also going to take row 2, I'm going to multiply it times negative 1. All right, to get rid of this negative 1 right here. And so it's going to give me 0, 1, 0, negative 1 half. Notice now I already have I2. 0, 0, 1, negative 4. That's my I3. And then down here I had 1, negative 1, 1, 0. Okay, so now I'm going to replace row 3 with row 3 plus row 1. And that'll get rid of this negative 1 right here. Almost done. Now I'm going to replace row 3 with row 3 minus row 2. And let's see, that will be 1, 0, 0, 3.5. That's my I1. Now I can just reorder these if you like, and I'll get 1, 0, 0, 3.5, 0, 1, 0, negative 1 half, and 0, 0, 1, negative 4. And then that's my I1, I2, and I3. Very nice. Okay, after get to class, we'll pause here. I'll come back to this in a bit.